Hello and welcome to the third episode of this mini-series in which we are trying to understand how to choose the best open weights model. In the first episode, we talk about the metrics that we need to know when trying to analyze an open weights model. And in the second episode, we talked about how we can access that model via a third-party provider. Now, let's talk about what happens when you decide to host the local yourself, either on a laptop or on a machine that you can access remote, like a server that sits under your desk. In order to understand the capabilities of this, we need to go back a little bit to the first episode when we talk about the four parameters, and one of them is quantization. Remember that quantization goes from 2 bits to up to 8 bits. So that means the lower the number of bits, the smaller the file, and the higher the number of bits, the higher the bigger the size of the file. Why is this important? Because the actual size of the weights file needs to be under the total number of RAM that your computer has. So this is the first metric that you need to have in mind. If you have a computer with 16 gigabytes of RAM, forget about running a model that is 72 bytes and it's not quantized. Or even if it's quantized, its size is about 40 gigabytes. You cannot squeeze 40 gigabytes of files into 16 gigabytes of RAM without a lot of quality compromises, which eventually render the model unusable. Now, the second thing that you need to know when you are starting to host models is that you have access to two architectures mostly. The first one is Apple Silicon, and the second one is NVIDIA. Let's take them one at a time. So Apple Silicon goes from laptop to desktop, MacBook Air, MacBook Pro, or Mac Mini, and Mac Studio. And it goes from 16 gigabytes up to some monster machines like 512 gigabytes of RAM, which is enormous and it costs like a small fortune. The biggest advantage of this specific architecture as compared with other normal PCs is that Apple knowingly or unknowingly made this RAM access specifically very fast, even before the AI comes. That's how the Apple Macs, Apple computers are built. You get a very performant access to the memory, which means you can make reads and writes to the memory that host the model very fast. Now, the other option is NVIDIA. NVIDIA is a very popular graphic cards builder, and it used to be famous for making huge GPUs, graphic processing units, with RAM ranging from 8 gigabytes to 24 gigabytes. Same as Apple, you can repurpose these GPUs to run models. So when you have a GPU like Radeon with 24 gigabytes, that means you can host an entire model in that GPU memory. On top of the GPUs that they are building, NVIDIA is also creating its own architecture using Blackbird, a technology, and a series of computers called DGX. You will see a lot of information online about DGX Spark, which is the go-to model because it's created by NVIDIA. Other vendors like Asus use the Blackbird specification and can create their own implementations, which sometimes are equally good and maybe cheaper than that. Now, let's see what kind of models you can run on what kind of architecture. So small models like quantized up to 4 bits, you can run in 16 to 32 gigabytes. So if you have a MacBook Pro, a MacBook Air with up to 32 gigabytes, you can run very interesting models and you get decent inference, not very fast and not very qualitative, but good enough for tasks that would have been unthinkable like just 1 year ago. For mid layer like 64 and 128 gigabytes, you can fit 70 billion parameters comfortably. That means you can have intelligence comparable with, let's say, Claude Opus or GPT 5.5 or Grok 4.5 on your own machine. That is already a huge advantage if you can afford the price of such a machine. The high-end game is when you have a mini studio or Mac Mini or Mac Studio with 256 gigabytes or 512 gigabytes, where you can run very complex model like DeepSeek V4 or Kimi Key 3. This is something not very affordable for many of us, but if you happen to have one of these machines, just keep in mind that you can repurpose it for having amazingly good inference in your on your desktop or in your server room. The nice thing about NVIDIA, one last word about this, the nice thing about having NVIDIA DGX Spark and to a certain extent having Mac Studios is that you can stitch them together. There are some connectivity ways like using specific switch or routers and cables that actually can put together the memory that you have on one station or on one Mac and give you a RAM space that is increasingly bigger. So if you buy two DGX Spark with 128 gigabytes each, you can stitch them together, you can stitch two of them together to suddenly have 256 gigabytes of RAM, which can fit comfortable a very, very professional model. Now, the problem is, how do you access all this intelligence? How do you use it on your laptop? How do you use it on your server? We will talk about this in the last episode when we talk about harnesses, but until then, let's try a short recap on this and let's try to understand what we know so far. So first of all, when we talk about open weights model, which are not the same as open source, we talk about parameter count, architecture type, quantization, and model type. These are all important in order to understand what a model is and how it can serve you. In the second episode, we learn how to access this via a third-party provider, and this is important when you need some convenience when you're on the road. And in this episode, we learned the basic requirements for running local inference, local open weights inference on your own hardware. Now, let's move to the last episode of this mini-series.